Solve without the use of a calculator. So this is a problem involving surds. We have a fifth root in the first bracket. Underneath that fifth root, we have the square root of 35 plus the square root of 3. In the second bracket, we have another fifth root. Underneath that square root, we have the square root 35 minus square root 3. So whatever lies under the fifth root in both brackets, they are similar. The only difference is the signs. Okay, so to approach this problem, we're gonna use surd laws, right? I have a root a multiplying, say maybe root b. So when we multiply the two roots, it's gonna be equal to the square root of a b. Okay, so you take the square root and multiply whatever is underneath each square root. So we're gonna do exactly that. So this is gonna be equal to, I understand I used a squared root. Here we have a fifth root. Irrespective of the order of the root, this rule applies. You have a third root, you have a fourth root. As long as the roots are the same, this rule applies. So we're gonna take the first bracket and multiply it with the second one. It's gonna be the fifth root of the square root 35 plus the square root 3 multiplied by the square root 35 minus the square root 3. Okay, just think of this, the entire thing under the first square underneath the fifth root as being a, and then whatever is underneath the fifth root for the second bracket, consider that or look at that as b. So what I did, I took the a multiplied with the b. I ended up with something like this. This is a multiplying b. Okay, so this reminds me of a difference of two squares, two things that are similar, two binomials that are similar. The only difference is the sign. So I'm going to treat this as a difference of two squares. So this will multiply that. The square root of 35 multiplied by the square root of 35, that is going to be 35. Okay, there's another rule for surds that states that if you have a square root, but this only applies when it comes to square roots, squared roots, square root a multiplied by square root a, all right, square root, and underneath the square root you have same basis. So when you multiply square roots that are exactly the same, you're gonna get whatever is underneath the square root. So square root 35 times square root 35, that's gonna be 35 minus times that positive. I mean, this positive times that negative, it's gonna be a negative. And then the square root of 3 times the square root of 3, same result as the 35, it's gonna be 3 equal to fifth root, and then it's 35 minus 3, that gives us a 32. Okay, so this is a number, but it can be rewritten into its equivalent power with a prime base. So that gives us what? 2 raised to exponent 5. So I basically changed the 32 into its equivalent power with the prime base, that is 2 raised to exponent 5. Taking the fifth root of 32, or 2 raised to exponent 5, it gives me 2. So this is the solution for that expression.